Okay, students. Now let's start the problem. Okay. We are going to write a differential equation. Write the differential equation governing the mechanical system. Mechanical system shown in the figure below. Okay. Let me first draw a mechanical system and see how to find out the differential equation that is supporting this system. You have studied the mechanical components as mass, friction and spring. Now on combination of all the three, we are going to merge it together and find out the effect of that. Okay, this is the question, problematic question. Let me write down first and then okay, this is the problem given for you. Okay. Okay. Now let's start solving the solution. First step, what we are going to do is, in the given system, what is the input? Input is f of t is the input. Okay, and for this the output, that is my displacement is x of t, that is the output. Okay, now in order to start with it, let's first see the Laplace transform of f of t. Laplace transform of f of t. How we will write that? Which is equal to L into f of t. I want. Okay. What is Laplace transform of f of t? It is f of s. Next, Laplace transform of x of t. How we will write? Laplace transform of x of t is x of s. So input and output we got now. This is input and this is output we have to find out. Okay. In order to do this analysis, we are going to study a method called as node analysis. Node analysis. Okay. For that, we are going to use free body diagram. For that, we are going to use free body diagram. Okay. Now let's draw the free body diagram. How to draw the free body diagram? Okay, this is just to find out the components what are present across the mass M1. Okay, which are the components present with respect to mass m1 we are going to see. Only for few problems once you start doing this method. Now after that you can, by seeing itself directly, you can start writing the equivalent circuit. But for first few problem you practice this method. Okay. You're going to draw the free body diagram. This is mass m1. Free body diagram of mass m1. How we are going to see? See, we are going to first analyze which are the effect that is affecting this mass m1. Okay. Now I'm going to do free body analysis. Where is my question? See. Okay, this is my question, right? Now till here I have to analyze. This is the effect that is linking with first mass. What are the things I have? Okay, I have x1 which is going out. So first what I should do? I should write x1 that is going out. Okay, next what I have with respect to this first mass, I have mass m1 affecting here. So f m1. Okay, this fm1 where it is, this is with respect to this mass m1. Okay, that means it is incoming force, that is force that is applied on this mass m1. Next I have k1. So where is this k1 present? It is towards the mass m1, so it is incoming. Next b1 is coming inside this mass m1. Okay, these three forces you are clear, right? fm1, k1, fb1, you are fine with it. Okay, next what is there? I have this dashpot b also linked with this mass m1. I have the spring also linked to this mass m1. So what I have to do? That force also I have to put fb and then fk. Is there anything else related to this diagram mass m1? Is there anything else attached to this diagram? No. Okay. Now you got these. Okay. You have already studied how to write the expressions for this. Okay. That let's see. Okay. What is F? F is force. F is nothing. What is the formula for F? Mass into acceleration. What was the formula you have found out? F is equal to mass into, what is acceleration? D square x by dt square. This you know. Okay. Next what you have found? F is equal to, this is with respect to mass. With respect to spring, it is k into x. With respect to dashpot, b into dv by dt, or which is equal to b into dx by dt. Okay. Now with keeping this as our base formula, we are going to derive formula for each one. Okay. First one is fm1. This is fm1 is the first one that is coming. How to get expression with respect to this itself? Mass that is used here is fm1 and d square. Which x is present here? x1. So it should be dx1 by dt square. Now for fm1 you got the formula. Okay. Next what I have? fk1 I have. Here just general formula is kx. So what I should do? Which k is using? K1 is used. Which x? X1 is related to this mass m1. So my k formula is this one. fk1 formula I got. Next fb. fb1 is there. So what should I write? b into, b should be b1. Then I have dx1 by dt. So now formula for fb1 also I got. Next what I have? FB. FB, what is the formula? B into dx by dt is the general formula. But where is this B present? B is present between two masses M1 and M2. That means it is in between two displacements x1 and x. So B should be having the displacement difference between x1 minus x. Okay. Now which B is used? It is B only. So it will be like B into d by dt. In the bracket, I have to write x1 minus x. So this is FB. Next what I have? FK. FK is k into x. In your question, where is k present? K is present in between M1 and M2. That is displacement x1 and x is having its effect on that. So Fk is equal to, k is k only. The name of that k is k only. X is what? What I am having is x1 minus x. So this is the formula for Fk. For all the terms, for all these terms, we got the expression. Okay. Next, what I have to do? I have to, by applying Newton's second law, that is Fm1 plus Fb1 plus Fk1 plus Fb plus Fk is equal to sum of all the incoming force. Do you have any outgoing force here? That is F of t is applied? No. So input is 0 here. Next task is substitute all the formulas in this equation. Okay. Fm1. What is Fm1? Fm1, what is the formula? M1 d square x1 by dt square plus Fb1. Fb1 means b1 dx1 by dt plus Fk1. K1 into x1 plus Fb. B d by dt into x1 minus x. Next plus Fk, that is k into x1 minus x. This is equal to 0. This is my equation 1. But it is all in which domain? It is present in time domain. But all my analysis should be in frequency domain. All my analysis should be in frequency domain. So what I should do? I have to take Laplace transform. Take Laplace transform of equation 1. Okay. How it will be? M1 is a constant. Next, d square x1 by dt means how I should write? S square x1 of s. Laplace means s should be mentioned. Plus b1 x1 of s, sorry, s into x1 of s plus k1 x1 of s plus b s x1 of s minus x of s. Next, plus k into x1 of s minus x of s, which is equal to 0. Now this is equation 1 for Laplace transform with respect to Laplace transform. Okay, this expression 1 with respect to time domain. This is with respect to frequency domain. So this equation 1. So this equation 1 is called as differential equation. It's called as differential equation of first mass. Okay. Next. Next, what we have to do? Next, write free body diagram. Write free body diagram of mass m2. So first what I should draw? I have to consider this mass here, m2. Check out which are the incoming force and which are the outgoing force. First, displacement x. Okay. With respect to this mass, you have to see x is outgoing force. Then I have f of t as outgoing force. Then f m2, f b2, then f k, f b over na 1 2 3 4 5 6 1 2 3 4 5 6. See, 6 terms I got. Now let's find out expression for each one individually. Okay, first before that, write Newton's second law equation. If this equation is correct, your problem is correct. That is fm2 plus fb2 plus fk plus fb is equal to f of t. It is equal to f of t. Okay. Now I am not going to write separately because I know. Okay. Now directly I am going to write. What is that? m2 s square x of s. Did we get? Okay. This is Laplace. Later we will write. Okay. Now with respect to mass m2, what is the thing you are getting? m2 d square x2 of t by dt square plus b2 dx2 by dt plus fk. What I have? K. Where is that k present? K is between mass m2 and m1. So I should write it as x minus x1. So it is x minus x1 plus b. B means dx by dt. Where is b present? B is present between m2 and m1. X minus x1. X minus x1. Now this is second differential equation or differential equation for mass m2. Now you have to take it in S domain. So what I want? Laplace transform of that. Alright, M2. Laplace of this is S square x2 of S plus B2 S into x2 of S plus K into x of S minus x1 of S plus B S of x of S minus x1 of S. This is the second equation in Laplace domain, frequency domain or in Laplace transform. Okay. Here only if you are next with after few problem you will be able to write here itself. Okay. Now let's solve this. Okay. These two are the differential equation. This is how you have to write the equation that is governing the mechanical system. Which are the two equation? This equation and the first this equation are called the equation that is governing the mechanical system. Once you have derived both, no, at the last you have to write like that. See, if your question is write the differential equation governing the mechanical system. Next you have to write it as differential equation governing the mechanical system. Or okay, first one m1 d square x1 by dt square plus b1 dx1 by dt plus k1 x1 plus b d by dt x1 minus x plus k into x1 minus x is equal to 0. Okay, equation 1. Next. Next, m2 d square x2 by dt square plus b2 dx2 by t by dt plus k into x minus x1 plus b d by dt x minus x1 which is equal to, okay, now here which is equal to f. This what is this f of t? In Laplace domain it should be equal to f of s. This is equal to f of s. This is equation 2. These are the two equations governing the mechanical system. Hope these two equations are visible for you. So you have to find out this equation. These two are the equations governing the mechanical system.